Okay, this is just a quick demonstration of smart queue management on OpenWRT for those people that are getting complaints about slow internet performance around the home or office, probably. It's to do with queue management and how latency sensitive TCP packets are getting stuck in very long queues in the regular routers you might find in your home or office. And this is how to solve it. So here we have the current OpenWRT software I'm using and the release I'm using. What we're going to use is Smart Queue Management, QoS, under there. You can get the details about how to install that from this website here. So let's go back. I have it set on now. Let's start quickly and start a test. So we'll run a ping to start with, see what we're getting now. So we're getting regularly getting 9 to 15 milliseconds latency with a ping when nothing else is going on the network, which is not bad. So let's run a speed test and see what happens. And nothing much really changes. Okay, it goes up a few milliseconds, 2 or 3 milliseconds, which isn't bad considering we're doing that download speed. As you're probably aware, upload is more important because that's where your outgoing packets are going to get stuck in buffers. But it applies both ways, I think. Okay, so we can see something there. And what you can see here is that this is the download speed I'm getting, and this is the upload speed I'm getting from the actual test. What I've done, I've got about 75 meg download from the supplier and 20 upload. This is what I normally get when I do a speed test without Smart Queue Management, but I've traffic shaped it, if you liked, to these speeds so that we are in control of the buffering rather than the service provider being in control of the buffer. That is, the speed where it stops getting faster to slower is in the router that I'm using, so I have control over it. Okay, so let's turn off the Smart Queue Management and see what the difference is. We'll start the ping again. I mean, already we're getting a difference, but not much again. But you can see there's something helping there already. But let's see what happens when we do the real acid test. Let's run the speed test again. Straight up. So you can see once the buffers fill up, we're starting to get about 75 latency, 75 milliseconds latency up to. Yeah, and the same with the upload speed as well. It's not quite as bad, probably about the same, more consistent upload. Okay, so that's quite interesting. What we could do also is go to DSL reports, and that has a built-in latency test in it, which is quite useful. It's easier than doing these ping tests. We're running over Wi-Fi at home here, so we'll have the buffers in the Wi-Fi access point I'm using too, but it doesn't seem to make a lot of difference if I plug it straight into the Ethernet anyway. So let's see what happens here. You can see it's got a buffer bloat meter in it too. So this is with it turned off. See, there's problems there coming in there. We'll do the same test with it turned back on again in a minute. So it's stopped, now it's starting again. You can see it's a bit wild. The buffer bloat meter is a bit wild. Okay. You can see we're getting the full rate I would normally get. Upload and download. And if we can scroll down here, we can see that we've got a B score rating for buffer bloat here. So let's turn back on the Smart Queue Management here. Looks like everything's back to normal again. Yeah, looking at the pings. We're going a bit lower. Let's run the speed test again. Okay, so it's running. Seeing a little bit of an increase. It's much lower. So the theory behind this, or the effect, the actual effect in practical measures that you would see from this, is that your internet performance would feel better for things like you know, voice traffic, your TCP connections if you're technically minded, anything that's delay sensitive, you know, like SSH sessions or even HTTP, you know, web browsing. Of course, everybody uses the web these days for video down streaming, don't they? So that might not come into it so much. But you can see we've got an A+ score now. Yes, people will say, if you look at the download and upload speeds, saying, yeah, but you've lost download and upload speed. Well, I would say to them, I don't need all of that speed. It would be nice to have more. I don't need it necessarily. But the overall performance of my network now for all applications, you know, the whole world of applications, is improved significantly because these deep buffers aren't being filled and blocking out, head of line blocking the latency or delay sensitive packets. So there you go.